Beautiful people, and welcome. In this video we are going to continue discussing graphing exponential functions. Now in the previous example in part 1 it did get cut off once again, so I'm going to go ahead and pick up from example number 1 and then go to example number 2 in this video. Alright, so when we left off in example number 1 we had just finished up solving all of these fractions with equations, and then we had our x values and our y values. So what to do with those x and y values? Well, you're going to have your input and your output. So for example, for your input was -2, your output was 18. So you're going to have input is -2, output is 18. And you're going to do that for all your points. Input is -1, output is 6. Next point I have input is 0, output is 2. Next point I have input is 1, output is 2/3, that's a fraction. And then the last one is input was 2, output is 2/9. Now I don't know what 2/9 is. For me that's very difficult to imagine. So what I'm going to do is I'm going to take my fractions and I'm going to convert them into a decimal. So I'm going to have 2 divided by 3, that's a decimal. I'm changing this point to 1, 0.67 because I know where 1067 is about-ish. And then same thing for this one. I'm going to change this point to 2, and I'm going to use my calculator to say 2 divided by 9, and that's 0.22. Now what I'm doing then is I am graphing these points. I have already done so in the previous part 1. However, the video did cut off, so you do see this already graphed. But what I did is I took each point and I graphed it. So -2, 18 is all the way up there. You can't really see it because it's off of the chart, but it's somewhere there. Then we have -1, 6, -1, 6. Then I have 0, 2, 0, 2. Then I have 0, and this is where the decimals help because I know that 6, 7 is closer to 1 than 0.22. And I'm almost noticing a little bit of a hiccup here, a little bit of a mistake, because this point is greater than 1. We don't want a point greater than 1. We want a point smaller than 1. So let's bring this point down here. So that's going to change our curve just a little bit. We're going to go down, and then this point 0.22 is even smaller. However, you have to keep in mind of our asymptote. Our asymptote is what is left over after our exponent, so in this case plus k. Now because k in our original example was not there, it did not exist, there was nothing there, that means our asymptote is at y equals 0, which means your horizontal asymptote, and it's always shown as a dotted line, horizontal asymptote is there. We shall never touch or cross that line. Can't do it. All right, beautiful people, let's move on to example number 2. For example number 2, we have this. Now, this is scary. There's so much happening here, but don't worry. Let's take it one step at a time. For the very first thing, is the domain given? Did they tell you what values to use for x? No, they only gave you the equation. So you get to choose whatever you want to do here. It doesn't matter. If you want to choose 37, you get to choose 37. I don't recommend it. I recommend smaller numbers, but you get the point. So what I'm going to do is I'm going to take my equation and I'm just going to copy it down. Make sure you're copying it down correctly. And even before that, let's actually stop there for a second. I didn't choose any points. I don't know how many times I need to rewrite my equation. So let's go ahead and just choose some x values. What do we want to choose? It ultimately doesn't matter. So let's choose, I don't know. Let's choose -1. Let's choose 0. Let's choose 1, and let's choose 2. Why did I choose those numbers? Because they're small, and I think they're the easiest to work with. Maybe. So now that I know how many I need to write down, so I'm going to copy my formula down that many times for each x value. Okay, Now I'm going to copy it down once again, but this time for my x values, I'm going to write down my points. So I'm going to have 1/2 times 4 to the -1 minus 1 power plus 3. I'm going to have 1/2 times 4 to the 0 minus 1 power plus 3. I have 1/2 times 4 to the 1 minus 1 plus 3. And I have 1/2 times 4 to the 2 minus 1 plus 3. Now you're going to solve one at a time. You can use a calculator if you want. I encourage using calculators. So I have 1/2. This is 4 to the -2 power plus 3. This is 1/2 to the 4 to the -1 power plus 3. This is 1/2 4 to the 0 power plus 3. And I have 1/2 4 to the 1 power plus 3. Evaluate the powers. Do that off to the side if you need to. This case here, I have 1/2 to the, make 4 a fraction, flip the fraction, keep the exponent, make it positive, plus 3, 1, oh, this should be a 1/2. I don't know why I put a 1/4 there. This should be a 1/2. Let's change that. So I have a 1/2 times 4, again, to the -1 power. So I'm going to make this a fraction, flip the fraction, keep the exponent as a positive. 1/2 times 4 to the 0 power. Anything to the 0 power is 1. And I have 1/2. 4 to the first power is just 4 plus 3. Now use your calculator if you need to evaluate your exponents. I'll show you how. So for example, I have 1/4 squared. So I'm going to put a parenthesis, 1 divided by 4 parentheses. So here's my 1/4. You can even do this all at once. Let me show you how. Let's start over. I'm going to do 1/2. So parenthesis, 1 divided by 2. So this is 1/2 times parenthesis, 1 divided by 4. But now I have an exponent. So I'm going to put this caret. So this button here, caret 2. And I'm going to press enter. That gives me a decimal. I'm going to add 3 to that. And then I'm going to convert to a fraction. Ooh, wrong one. There it is. So this gives me 3 1/32. Now I am okay if you give me a decimal. Because you are graphing this, I am okay if you give me a decimal. For me personally, decimals are easier to graph than fractions. Let's do that one more time here. Parenthesis 1/2 times parenthesis 1/4 to the first power. You can do that if you want, just to keep everything the same. I'm going to add 3 to that. So let's keep this as a decimal, 3.125. So we can see that our numbers are going to get bigger. Let's do that one more time. 1/2 times 1 plus 3. I have 3.5. And I have 1/2, parenthesis, 1/2 times 4 plus 3 is 5. So you can see it's getting from small to big and then really big. So now that we have our values, we're going to write out our points. Remember, input, output. So input, output, input, output, input, output, input, output. Graphing our points. Let's create them first. So our input, I'm going to shift this up. Our input was -1. Our output is 3.03. Our input is 0. Our output is 3.125. Input is 1. Output 3.5. And input is 2. Output is 5. So we're going to graph. I recommend creating your own graph. Don't use something that's already pre-printed because you can make things work your own way. This is -1, 0, 1, 2, 3. And this is where I mean you can make things your way. I need a lot of 3s and I need to go up to 5. So 1, 2, 3, 4, 5. And you can make it bigger. So let's go ahead and graph these points. Negative, I'm going to choose this one to do 2 and 5 first, just because it is 1, 2, 3, 4, 5. The easiest one to graph. Then I have 1 and 3.5. So here's, ooh, did you see, you guys, that I put 3 there? Should be 1. I can count. So 1 and 3.5. So 1, 3.5 here. Then I have 0 and 3 and 1.25. Then I have negative 1 and even smaller. We're not touching 3 yet. We're not touching 3 yet. So let's go back here and talk a little bit why we're not touching 3. Notice the value after the exponent, this value right here. Remember our conversation. This is your asymptote. That means y equals 3. They have a horizontal asymptote. So this is a horizontal asymptote. We will never touch or cross this line. So we're going to get super duper duper close, but we're never actually going to cross that line. So let's go ahead and connect our points. This is a continuous graph. So it's going to go up. Here on this side, it's going to continue getting closer and closer and closer. Make sure when you're graphing, you leave a gap to show that we are not actually touching our asymptote line. All right, beautiful people. Thank you so much for watching. Hopefully this video does not get cut off, and I will see you in my next video.